Hey, folks. This is the beginning of chapter 9, which is all about sequences and series. Turns out sequences and series are pretty easy, and you might have learned about them at another point. The sequence is just kind of a collection of something, usually in a pattern. Now, it's usually a collection of numbers or variables. It could even be A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. You get the point. But first off, I should tell you all these notes are on the topics page under chapter 9. Second of all, the important thing to know is that these values right here, a sub 1 just means the first term in the sequence. A sub 2 is the second term in the sequence, and etc. All the way up to a sub n. That's a common one. That just means the nth term. We use that when we're trying to generally describe something. Now, two examples of this. This is an explicit formula for a sequence. That means if I want to know the first, second, or third terms that are over here on the right, I can plug in 1 for n to get the first term. I can plug in 2 for n to get the second term. Or if I wanted the 103rd term, I could just plug in 103 for n. And it would spit out a number that would be the 103rd term, way off, about 100 past those. Now, a recursive definition means you have a starting point. They give you the first 1 or 2 or 3 numbers, and then they give you a formula for how to get the rest. And here's the deal. If you want the 50th term, you probably need to know the 49th term first. But to get the 49th term, you might need to know the 48th term. So you can't just jump ahead and find any term that you want. You need to go in order using this recursive definition. But once again, up here, this example, these are the first 4 terms in the sequence. Now, it shouldn't be real surprising if something converges, that means it is moving towards one number. Notice that these numbers, example 1 down here at the bottom of the page, if I plugged in 1, 2, 3, 4, and 5, maybe 6, I get numbers that seem to be, the farther the sequence goes, getting closer and closer to 3. Therefore, we'd say that it converges to 3. And if it doesn't converge, if it doesn't seem to be getting closer to one specific number, it just happens to be going up by 4 each time, that means it diverges. So, okay, that shouldn't be too big of a deal. We'll also take limits. No biggie there. We've done lots of limits. If it's indeterminate, don't forget to use L'Hopital's rule. And there's some other terms here like monotonic. That just means it's always increasing or always decreasing. Upper and lower bounds just means, hey, like this example up here, what's the biggest number that you would have in your sequence? Well, they get closer and closer to 3. It never really approaches 3, but 3 is the upper bound. Turns out there is no upper or lower bound for that second example because the numbers just keep going. Oh, actually, there is no upper bound. Technically, the lower bound is just 1 because that's the smallest number. But that's just definitions. You won't necessarily need to know monotonic and upper and lower bounds. You will definitely need to know what a series is. And that's what happens when you add up all the terms in a sequence. If you add up all infinite number of terms in a sequence, that would be a series. And if you're not feeling quite that ambitious, then maybe just add up a few of them. A partial sum is where maybe you add up the first 3 terms. Or as if it was S sub 50, you'd add up the first 50 terms. We're going to spend a lot of time deciding if series converge or diverge and what they approach. So that's going to be a really important theme in chapter 9. That's probably going to be it for this video because I think I'm running out of time, but we'll talk about some of the specific series we need to use later on.